So today we're going to start talking about monomials. We've actually really used monomials, we just haven't called them that. So a monomial is a number, a variable, or a product of a number and one or more variables. So some examples would be just x, that would be an example, 2, x, y, z would be an example, 3y would be an example. We're going to learn several rules when we're multiplying monomials. The first rule we're going to look at is if you're just multiplying two monomials, the rule is if the bases are the same, they're both a's, you can add their exponents. And then when you have something like this, a power raised to a power, you multiply the exponents. And when you have a quantity raised to that power, it means everything inside is raised to that power. So your lesson today is really just using these rules and applying them in different situations. Now I probably will put in a few more steps today, but normally we don't put in all these steps. So here I'm really multiplying two monomials, so I'm going to go back to that rule which says if the bases are the same. Well, what's the number in front of this x to the 6th? It's really a 1, so it's really 5 times 1 times x to the 7th times x to the 6th. And 5 and 1 are just regular numbers, so that's 5. Here we have the bases are the same, so we add the exponents and get 13. So 5x to the 13th would be our answer on that one. Now normally you don't really need to write it out like this, but I just wanted you to understand. So I'm going to probably do the next one writing it out and then I'll stop. So if I write my numbers together, 4 times -7, then have an a and an a to the 2nd, a b to the 6th, and a b to the 3rd. So 4 times -7 would be -28. My bases are the same. You have to stop and think, what is the exponent on this a? Well, it is a 1, even though it's not written in. So you would add those and get a to the 3rd, and then add over here and you get b to the 9th. So you don't have to write it out like that, but that is what it means. And so usually we just put them all together, just multiply like 4 and -7 and just do it from here. Here we have a power raised to a power. So going back to the first slide, you see the rule when you have a power raised to a power is the base stays the same, but you multiply the exponents. So it would just be x to the 8th power. Here we need to start inside. We have a power raised to a power. So when we do this first one, 3 squared raised to the 3rd power would be 3 to the 2 times 3 is 6. But now it's raised to the 2nd power, which would be 3 to the 12th. And on this one, we're going to just let you leave it. You don't have to figure out the number for that. Normally we do figure them out if it's just a littler problem, but this one we can just leave like that. In this example, we have a power raised to a power, but there's two things inside. So remember, both those exponents are 1, so it would become x to the 4th, because 4 times 1 is 4, and y to the 4th. Here again, we don't usually write this step out, but some people forget the number. Remember, it's 5 to the 3rd, it's x squared to the 3rd, it's y to the 3rd, and it's z to the 3rd, all to the 3rd. So normally we just kind of do it in here. Well, 5 to the 3rd, you do need to figure this out when it's in a problem like this. 5 times 5 is 25, times 5 would be 125. X to the, again we're multiplying exponents, 6th. Y to the 3rd. Z to the, 3 times 3 would be 9. That's kind of a messy 3 there. That's a messy 9 there, but hopefully you can read it. So this one I'm not going to write anything out. I'm just going to do it. I'm going to multiply my numbers because they're normal multiplication. I have powers of the same base, so I'm going to add their exponents. 4 plus 2 would be 6. Powers of the same base, I'm going to add their exponents and get 4. So 36, a to the 6th, b to the 4th would be my answer there. Here I'm just multiplying three monomials. The bases are all the same, so all I do is add their exponents. 1 plus 4 plus 6 would be 11. X to the 11th. In this problem, I have a power raised to a power, but I have to distribute it really. I don't know if distribute's the right word, but take everything to that power. So 3 to the 2nd power is 9. Y to the 5th to the 2nd power, remember a power raised to a power, I multiply the exponents. And z to the 1st to the 2nd would be z to the 2nd. And one last one similar to that number one. So 3 times 2 is 6, so 2 to the 6th. All to the 3rd would be 2 to the 18th, and we can just leave it like that, and we would be done.